Good morning to all. Welcome back to the day 5 of our FDP. We will start in 5 minutes. Vishwa, sir.
Yes, sir. We'll start. Arun sir, my voice is audible.
Yes, sir. Yes, sir.
Good morning, everyone. Welcome back to the session of this FDP. And today we have with us for this session Dr. M. Venkateshkumar. Dr. M. Venkateshkumar currently serves as Assistant Professor in the Department of Electrical and Electronics Engineering, Amrita School of Engineering, Amrita Vidyapeetham, Chennai Campus. He has over 12 years of teaching and research experience and has specialized in the area of power system engineering. Presently, he is also the associate editor of IEEE Access Journal and is the guest editor of some special issues like artificial intelligence and IoT-based grid integration of renewable energy system and electrical vehicle application. And MDPI Energies, which is a Web of Science journal, and guest editor for some special issues like modeling of artificial intelligence controller for microgrid and smart grid application, energy engineering, tech science press. And he is the chairman of IEEE professional activities and vice chairman of IEEE Power and Energy Society IEEE Madras section. He is also a member of IEEE P825 and P2030 research working group in USA. He has made significant research contribution in the area of design and control of artificial intelligence-based hybrid renewable energy source for on-grid and off-grid application. He has published more than 60 research papers in international journals and conferences. He is a review board member for more than 40 international journals, conferences, and special session chair in an international conference. Recently, he published his research paper titled On Modeling a Pumped Storage Hydropower Integrated to a Hybrid Power System with Solar Wind Power and its Stability Analysis in Applied Engineering Elsevier, having an impact factor of 8.848. He has served as a reviewer of IEEE Transaction, Elsevier, Springer, and other reputed peer-reviewed journals. He has authored 3 books uh, in Elsevier and Intercoven Publication UK. He has received the prestigious Young Scientist Award from Govt of Tamil Nadu. He has also received the Outstanding Contribution Award from MATLAB USA for 3 consecutive years, 2015, 16, and 17. He has an international copyright for 70 research simulation projects and designs from MathWork. He has been holding a global ranking of second position in MATLAB Central Simulation Designer portal out of 15,000 designers worldwide. With this small introduction, I would like to invite Dr. M. Venkateshkumar. Sir, the session is handed over to you. Thank you.
Yeah, good morning. Yeah, thank you for your warm introduction. Am I audible now?
Yes, sir. It's audible.
Yeah, can I share my slide?
Uh, Not shared till now.
Yes, sir. Yes, sir. You can.
Yeah, thank you. Hope it is visible.
Yes, sir. Visible, sir.
Yeah. Yeah, good morning, Honorable President. Yeah. First of all, I would like to thank the organizer Dr. Arun Mehta, to give the wonderful opportunity to give the presentation from the audience. So may I know, so all are in triple background or sorry, EC background, I think so, because this event is organized by EC. Fine, fine. Okay,
Yes,
today
sir.
I'm going to discuss about. So my presentation is purely is a AI based grid integration of renewable energy system and its challenges. What are the challenges we are facing when we are going to integrate the renewable energy sources into the power grid? So from here we are going to use the artificial intelligence and smart grid. Actually, whenever the artificial intelligence is involved in power grid, so normally it will convert into the make it smart. So like that, I will start my presentation. Okay, this is my presentation overview. First of all, I'm going to discuss about the overview of artificial intelligence. So I'll give some introduction slides for AI. So what is AI and what is the history of AI? Then after that, I'm going to discuss about the smart grid. So what is smart grid and what are the benefits? What are the main characteristics and benefits of the smart grid? And then I'm going to discuss about NSGM. Is nothing but the National Smart Grid Mission of India. Then distributed renewable energy sources like solar, wind, PV fuel cells, like that. Then what are the topologies we are using now presently in hybrid renewable energy systems? Then few simulation models. Then after that, we are going to discuss about what are the challenges we are facing when we are integrated with the power grid, the renewable energy system. Finally, the international standards. Okay, what is AI? This is the first one because the smart grid is a backbone is the AI. Without AI, we can't to convert our normal grid into smart grid. That's why the smart our grids are very smart because is the backbone is artificial intelligence. So everyone know about that wherever you go, wherever you attend the events or presentations. So they are definitely they are touch upon the AI because the AI is in a current trend. Even many of the universities they are started for uh, bachelor degree with the AI, artificial intelligence. So there is a importance, that much importance are there in future in AI because AI is not yet new. Is more than 50, 60 years back they have started the innovations and researchers in AI. So first of all, what is how we are going to understood what AI? What is AI? So one can this is my presentation is somewhat is a full and full some interaction sections you can so anyone can answer what is AI?
Artificial intelligence.
Yeah, artificial intelligence. I'm asking about what is artificial intelligence? So we
The
have
machine
artificial
can
intelligence.
do the performance
Yeah, machine can performance.
based on the trainings,
Yeah,
predefined trainings, and they can make their own decision.
good. Is correct. So this is machine or human? Okay, this is the human. So human, he thinking to solve some problem or he thinking to solve otherwise take some decision to solve the problems. Okay, so how he can do that because he have the knowledge, he already have some set of knowledge because he is a degree holder or master or doctorate, whatever it is, because some humans they definitely have some knowledge because the natural intelligence. Okay, so that is the reason they can do think and they can do solve the problem. Okay, so this is the natural characteristics of the human. So what is this? This is the machine. So the whenever the machine mimic like a human brain is called artificial intelligence. Okay, how we are going to convert? How we have to understand the artificial intelligence? Someone or something has to have a brain, or in other words, the organ that enables someone or something to learn and understand things, to solve problems and make decision. Okay, that is a very important one. So we can to define intelligence as the ability to learn and understand to solve problems and make decision. So this is the AI. That's why. So human, we have the natural intelligence, we have the ability to learn and understand to solve the problems. So the same characteristics, whenever we provide the characteristics for the machine, okay, the machine or something, okay, so the machine also should have the same intelligence to ability to learn and understand to the solve the problems. So that is called the machine mimic like a human brain. Okay, so that is called artificial intelligence. So what is artificial intelligence? So what are the main characteristics involved? So whenever you are going to design intelligence, so we can't say all the algorithms are intelligence. That's why they say that people define intelligence in many different ways. However, you can say that the intelligence involves certain mental activities. There is a composed mental activities of the following. First one is the learning. That is the first step is the learning. So the machine or example this artificial intelligence, the machine having the ability to obtain and process new information. So that is why learning process. The next step, reasoning. So based on the learning, it is able to manipulate the information in various ways. The next step, understanding, considering the result of the information manipulations. The next step is grasping truth. So based on the manipulation results, it will going to determine the validity of the information. Then next step is seeing relationship, defining how validate the data interact with other data. Then after that, the consider the meaning, apply the truth to the particular situation in a manner, consider the relationship, separating fact from the belief. So from here, we are going to determine whether the data is adequately supported by the provable source that can be demonstrated to the consequently valid. So these are the composed activities. First step, we have the machine should be learned from the new data, and that is a new informations. It will get to gather the data and process the new information. After that, after the learning, uh, the machine should be able to manipulate the information in various ways, is the data analysis. Then after that is understanding. So from the information, the manipulated information, it will going to consider the results. So whether the considering the result of the information of the manipulation. Then after that, it will going to check the validity of our result. Then after the validity the result, it will how the data are interact with other data, because when we know whenever you are going to provide the training for artificial intelligence, we have a set of data. Example, you have 100% of the data, so we are going to provide 70 to 80% for the training. The remaining data we are going to use for the testing and validation. So like that, this is one is not a boundary. So yeah, apart from the boundary level, how the data are interact with other data. Okay, that's why the seeing relationship, they consider the meaning when we are going to apply the truth to the particular situation, how it will react. Then finally, so whatever the data you are provided is adequately yeah, supported. Otherwise, at the same time, we need to check our data are true data or false data. So that is another important one. Okay, so this is the introduction of AI. We have a set of activities, the mental activities. So discovering, we have to say the AI in the 4 ways. So I go forward this slides. Is acting humanly. So how we acting humanly? So acting humanly is nothing but, so whenever the machine is a learn how the human is acting in the different situations, how it will going to learn the data. Then thinking humanly, that means how the human thinking. So what are the uh, limitations, what are the environmental constraints they are follow, what are the set of rules they are follow. So they are machine thinking like humanly, that means the machine start thinking. Then thinking rationally, so how, what are the data we are follow the rationally. The next one, acting rationally of the AI. This is the 4 ways, very important 4 ways we are going to define the AI. These are the fundamental things. So I am, because due to the time constraint, I'm going to forward. Okay. So the understanding the history of AI. So what is the history of AI? So whenever the computer, the personal computer is innovated, at the time we are using the machine language or ones. So we know the logics 0 or 1. Then after that, that is called yearly algorithm. We are using the logic gates. Then after that, it comes to the expert system. Is developed by expert system. Then neural networks, machine learning, deep learning is currently we are using deep learning algorithm. So the timing, the 1960s and 1970s, we are using early algorithm, then expert systems like fuzzy logic controllers. The later 1980s and 2012, so we are using the same expert system, neural networks, machine learning algorithms. At present situation, after 2012 to present, we are focusing on deep learning algorithms. So how we are going to classify the artificial intelligence? So the first one is the weak method, artificial narrow intelligence, strong method in AI, artificial general intelligence, artificial super intelligence. So what is weak method? So weak method means is not a weak technology. So the weak method and artificial narrow intelligence is both are focusing on a particular application only. Is it will example in your mobile, there's a human assistance. The mobile phone, if you are using the Apple, the C is the one of the narrow intelligence. Then another one is autonomous vehicles, also the narrow intelligence. We'll discuss that one by one. The weak methods, from here we are going to provide the data only for the simple operations and particular mathematical calculation and mathematical decision making. So this is for using only for the particular applications. So from here we are using only for the logic reasoning and other general structures. So from here we did not provide any emotional and real conscience of their system to the system. So this is it's only simple system, but at the same time it will work only for the narrow applications. So this is Alexa and C is the example for the personal assistant using the weak method in AI. The strong method in AI, from here we are going to provide say the processing time and the very good processing power and good data, is it provide enough intelligence data. From here it will deals with the present situations and real time emotional data. So everything we are going to provide the AI system, then only it will perform very well. From here also we have to deal with knowledges. Is a knowledge we are going to provide. That's why we are going to provide the that means efficient processing power with um, enough intelligence. Then only the system is perform, can literally think and can consciously the same way that human is conscious. That is a very important one. The strong method. The narrow intelligence is we know that machine intelligence that equal or exceed the human intelligence or efficiency at the specific task is only used only for the specific task like autonomous vehicle, translate, like playing the artificial intelligence, chess playing, digital smartphone assistants, and self-driving cars. So these are some of the example for artificial narrow intelligence. Then next one is artificial general intelligence. That is another important one. A machine with the ability to apply the intelligence to any problem. From here, the example, if I say, I think most of them seen the film is a Terminator. So Terminator is one of the general intelligence. Okay, from there the machine with the ability to apply the intelligence to any problem rather than just one specific problem. That is a human level intelligence. So from here some of the examples they are given, built to improve the capabilities comparable to the humans. So HAL in 2001. The Space Odyssey is a film. The intelligence powering R2D2 in Star Wars, and human-like AI seen in the movie of Her. So these are the general intelligence is there, but is not practically is now is not not available, but is only in the film level is only available the artificial general intelligence. The next one is artificial super intelligence. So from here, so what is the difference between the general intelligence and super intelligence? The general intelligence is a human level intelligence. Okay, so like that based on the training of the human. But general level, there is a super intelligence. That intelligence is much smarter than best human brains, in particular in every field, including scientific creativity, general wisdom, and social skills. So previous only the human. So based on the human knowledge, we are going to provide the training. Then based on your training, it will perform. That's a general intelligence. Super intelligence, the best human brain in the globe is it is much better than there's a better at the same time much smarter than the best human brain. So like that, we are going to provide the training, we are going to provide the enough the data, the knowledges. Okay, but this one also under research area only. It's in artificial super intelligence. Then AI types. So we have the AI artificial intelligence. It's a machine learning, natural language processing, speech, expert system, planning, scheduling, optimization, robotics, vision. So under the machine learning is a deep learning, predictive analysis. Is a deep learning and predictive analysis one of the hottest area for the research, and translations, classification, clustering, and information extraction using natural language processing (NLP). Then speech to text and text to speech, also the intelligence, the expert system, physiologic controller, the planning, scheduling, and optimization is also available. Then robotics, we are using the robotics also artificial intelligence, vision, image recognition, vision, video processing, and image processing. From here, the autonomous vehicles is also is under this research area. So these are the some of the AI types. Yeah, I think it's okay. I'll explain this one. So yearly algorithm. So what is the yearly algorithm? So whenever we are going to design the computing devices, they mimic the human ability to manipulate the simple in order to perform the basic mathematical tasks such as addition, subtraction. There is a mathematical task only it will do that is based on the logics. So the logic reasoning later added the capability to perform the mathematical reasoning through the comparison, such as determining whether one value is greater than other values. This is the logics we are applied. However, the human still needed to define the algorithm used to perform the computation, provide the record data in right format, and then interpret the result. This is the earlier algorithm is a very old algorithm. Now the next stage is the expert system. In 1970s, the expert system is developed. Then after that is 1980s, it will come to the market is a real-time AI system. There's a knowledge of experts. That's why it will the knowledge system. So from here, the expert system, how we are going to develop the expert system? So the meaning of the expert, that is called the experts only can develop the controller, not for others. So whenever you want to develop any controller, you should know that research that area. Example, you are going to develop any motor controller, you should know. So A to Z of the motor operation. Otherwise, if you want to control, if you want to do any image processing or video processing, so you should know about the A to Z of the image processing and video processing. Then only you can to develop the controller using expert system. That's why the developer should be expert. Then only you can to develop the controller. That's why the expert system is the advantage and disadvantages also. So the unknown people develop the controller does not perform well. That's why is a human should be expert. Then after that is discuss with the knowledge engineer. Then they are going to develop the controller. It's a knowledge based interference engine and finally interference. But the user may not be an expert. But only thing, whenever you are going to develop the controller, there's a developer should have the A to Z of knowledge of the system. That's why this is the first truly useful and successful implementation of AI in 1980s. This is the first milestone of the AI. Then this is some of the rules representation techniques we are using for the expert systems. There is a relations, recommendation based, directive, strategy, and heuristic based rules based system. First one is the relation. What is the relation? If the fuel tank is empty, then the car is dead. This is the relation. What is the relation between the fuel tank and the car? So if the fuel tank is empty, then the car is dead. That's all. The next one is a recommendation. If the session is afternoon and the sky is cloudy and the forecast is drizzle, then the advice to take the umbrella. This is the controller. It will provide the recommendation. The next one is a directive. If the car is dead and the fuel tank is empty, then the action is refuel the car. This is the directive. The next one is the strategy. If the car is dead, then the action is check the fuel tank. The step one is complete. If the step one is complete and the fuel tank is full, then the action is check the battery. The step 2 is complete. Is like this, continuously step by step. It will provide the information. Then another one is heuristic. If the spill is liquid and the spill pH level is less than 6 and the spill smell is a vinegar, then the spill material is a acidic acid. So these are the recommendations. So these are the rules based systems we are using in the expert systems. The neural network is another important area. Artificial neural network. There is the simple neural network and deep neural network is only simple different. So simple neural network is a shallow type, that is only one hidden layer or two hidden layers we are using. But in deep learning algorithm, from there is a minimum 10 hidden layer to 100 hidden layers we are using in the deep learning algorithm. That's why the input layers. So these are the input layers, hidden layers, and the output layer. So from here we have the many mathematical operations are there in behind the design the neural network. It's like that is whenever you are going to use the feed forward network or coconut network, whatever it is, we need to design the weights, base value, activation functions. Okay, these are the plenty of operations are there behind inside your system. So machine learning. So what is the advantage in machine learning and deep learning algorithms? So in AI is currently in a new high in the phase because of the machine learning. A technology that helps computer learn from the data. Having a computer learn from the data means not depending upon the human programmer to set the operation task, but rather the deriving them directly from the examples that show how the computer should behave. So we know the machine learning. So whenever you come to the artificial intelligence techniques, there is a ANN. From there, we have the different type of learning algorithms are there. There's a supervised learning, unsupervised learning, reinforcement learning, semi-supervised. There are plenty of learning algorithms are there. So some of the learning algorithm, unsupervised learning algorithms. So without the human intervention, without the labeling data, it will learn from the data. So for the classifications or clustering is based on the data, it will do that. So from here the machine learning algorithm in the picture, the input is the car, that is the feature extractions. We are going to give some the characteristics of the car to the network. So from here the network will train. So after that, if you provide any information to the network, it will check whether it is car or not a car. So if you give the picture to the car picture to the network, it will show this is a car. The same thing. So if you show the different picture to the network, it will say the output is not a car. This is the machine learning algorithm. The next one is a deep learning algorithm. So the deep learning algorithm, the feature extraction and classification of get together in the network. So whenever you are going to provide the data, is the input data to the deep learning network, then based on the network, it will classification is whether it is a classification or regression or clustering is based on our applications. So from here, what is the need? Why we need to move machine learning to deep learning algorithm? So there is a only important thing. So the machine learning algorithm or earlier algorithms, the amount of data, the training data is one of the very important one. So whenever the amount of the data increase, one certain the time of the data level, the performance will be going to settle down here. Example, this is the older learning algorithms, the performance goes to settle here. But so whenever they increase the amount of data, the performance of the machine learning algorithm it is goes to increases. That is the reason we are going to move the deep learning algorithm from machine learning to deep learning algorithm. So these are the some of the general pictures is available in the website. Is artificial intelligence. And under the artificial intelligence, we have the machine learning algorithm. Under the subset of the machine learning algorithm is deep learning algorithm. So these are the application area of artificial intelligence. So the few AI deeply integrated in Google products. Okay, now I come to the smart grid. So why smart grid? What is the need? So conventional power grids, there is one-way communication. It's not a two-way communication. But the smart grid is a two-way communication in between utility and the customers. That's one of the advantage. And the sense along the transmission line is what makes the grid smart. So this is the two-way communication in the smart grid. So link the internet. What are the main parts are in smart grid? So one of the IoT. The smart grid will consider control computers, automation, and new technologies under the equipped working together. But in this case, these technologies will work with the electrical grid to respond digitally to our quickly changing electrical demand because it's a two-way communications. The same time is a purely is IoT. Is that there is a multi-agent systems are there. It will always monitoring your performance and your energy consumptions, and after that it will going to communicate to the utility to the consumers. If you have any changes, is a digitally response is a fast response. If you have any fault occur, it will provide 24/7 power supply without any interrupted power supply. It will provide by the smart grid. So what is the benefits? So the more efficient transmission of electricity, the quicker restoration of electricity after power disturbance, reduce operation and management cost of utility, and ultimately low power cost of the consumers. Because whenever we will reduce the operation cost and management cost, so finally it will impact to the consumer uh, tariff only. So if it is reduced, the operation and management cost is ultimately the low power cost for the consumers. The tariff will be less. Reduce the peak demand, which also help the lower electricity rate. Increase integration of large scale renewable energy systems. Better integration of consumer owned power generation systems, including renewable energy sources like that. The consumer owner power means we have to install the rooftop, the solar or wind. The excess power we have to sell to the electricity board. Then finally, it's a improved security. So security also very important one in the smart grid, because it's like people are know is easy, people are know the networking. So networking means we are going to provide the network for all interconnect all the systems. So like that we are going to integrate all the power plants, all the power grids. So if you have anyone is hack your system, so totally is a blackout and brown out the power supply. So that is why the security is very important one. Then what are the characteristics of the smart grid? First one is the optimize. So the optimize the asset utilization and operating efficiently. So it will optimize means it will optimize asset utilization. So it will utilize the power generation sources, then the transmission path. So everything it will going to utilize the optimally utilize all the information, all the data, and operating efficiency. At the same time, it will give the more efficiency. That is the first characteristics. Then accommodate all generation and storage options. So here we have to accommodate renewable energy sources, non-renewable energy sources, and battery storage. So it will accommodate in the system. It will provide the power quality, the range of needs in digital economy. It will generate. That means it will provide the good quality of the power to the consumers. Then only we have to increase the lifetime of the appliance. The anticipate and response to system disturbance in self-healing manner. This is the very important part of the smart grid, the self-healing manner. From here only we are going to apply or AI technologies. That is the reason the network is called smart grid. The next one is operate recently against the physical and cyber attack and natural disaster. Enable active participation by the consumers and enable new product and service and markets. This is the characteristics of the smart grid. Okay. The next one, adaptive and self-healing nature. So what do you mean by adaptive and self-healing nature of the smart grid? The smart grid being adaptive meaning it less reliance on the operator. So from here, the operator, the human interference is very less. Is it because it's a purely is operated by the AI? At the same time, the self-healing. What is the self-healing? That means it has any problem. Okay, that means it has the capability of automatically repair or remove the potentially fault equipment from the service before it fails. It's not after the fails, before it fails, because from here we are going to use the predictive maintenance, the AI based predictive maintenance. So the system continuously monitoring your performances is the performance and all the characteristics is continuously monitored because it's a multi agents. There are plenty of sensors are there, so they are collecting the data and the data analysis is there. Then it will do based on the data analysis, it will going to start the predictive maintenance of the system. That is the reason the self-healing power is there in for the smart grid system. That's why the capability automatically repair or remove the potentially faulty equipment from service before it's failed. Is the normally in our power grid, if it is any failure is occur, so what will happen? The circuit breaker or tripper will isolate the fault equipment from the service. Okay, that is after the fault. But from here, it will sense, it will predict the system faults before. So if it is possible to solve, it will solve the problem. Otherwise, before the failure, it will isolate. At the same time, it will provide the electricity 24/7 to the consumers. How it will provide? It will going to automatically reconfiguring the system in such a way to ensure the continuity of the energy to all the consumers, because the smart grid is interconnected to all the network and consumers. So it will reconfigure the flow of power. The next one is the flexible. We already discussed about the flexible. That means it will accommodate all the energy generations and storage devices. But why is flexible? What about our power present conventional network? Is a conventional network is not flexible? Yes, it's a conventional network is not flexible, because if you want to integrate any renewable energy sources and storage system to our power grid, we need to get the permission. Then we need to check the common coupling point. Then only we have to integrate the renewable energy sources. A large renewable energy size is normally in our home we are using 1 kilowatt, 2 kilowatt. This is not a problem. Whenever I said in megawatt and 100 megawatt, otherwise 1 megawatt plant, so we need to get the permission and interconnect with the grid from the electricity board. So from here, the smart grid, it has the ability to rapid and safe interconnection of the distributed generation and energy storage at any point of the system at any time. That is the flexible compared to our conventional source. This is the predictive maintenance, is already I discussed there. Integrated, so that's why it's all the systems are interconnected. It's a network. That's why this is particularly important in the terms of real-time communications and control functions. So this is a very important one. At the same time, so all the systems are interconnected. For example, if anyone is the failure is there, any one connection is failure, but the system is reconfigure the path of the power flow. That is the reason we will provide the continuous power to the consumers. Interactive, yes, it's a very interactive one. There's a two-way communications in between the consumer and the utility. The optimization. So one of the from here also we are using AI technologies for the every major components in real or near real time, and having the control equipment to provide the optional routing path that provide the capability of autonomous optimization. Is not a normal optimization, it's autonomous optimization of the flow of electricity through the system. So why we are using autonomous optimization systems? So we have to increase and maximize the reliability, availability, efficiency, and the economic performance. That's why here also we are going to use artificial intelligence. Then security. So very important one in smart grid is a security level. Since the two-way communication, the capability of covering the end-to-end system is considering the fundamental and basic requirement of the smart grid that need the physical as well as cyber security of all critical assets are the essential. So whenever they extremely important to ensure the smart grid is a secure from attack and natural occurring disturbance. So if anyone is attack or hacking your network, just imagine in global all the power plants, all the power grids and substations and consumers are interconnected. If anyone is hacking your system, they can to control your equipments and your systems, everything in he can do in single place whenever hack the whole network. So that's why the cyber security is one of the heart of the smart grid. So if failure, the cyber security is failure, definitely we have to say the smart grid is failure, because the security is very important one in the smart grid. So like that, that's why I said the cyber security is the heart, our AI is the brain, and networks are our nerves and backbone. Okay, there's a backbone is the interconnection path. Okay, so if it is heart is failure, the smart grid is failure. If it is nerves, the network is failure. Yeah, example we have to say some nerves are failure, we have to replace it. Otherwise we have to example some most of the nerves are there, some we have to replace it and we have to adjust somewhat. But the backbone and brain failure, the whole system, and heart failure, the totally is down. That's why the heart failure is there. So totally the system will be set down. If it is brain failure, the system is not perform well. So that's why I said it's a very important one, the cyber security of the smart grid. Okay, these are the some of the international standards in IEC 61850 and its application to the smart grid. So if you have the time, you have to go through this standard. They give some many informations about smart grid in India. So what about in India, the smart grid? Okay, we have the National Smart Grid Mission, is the NSGM, is under Ministry of the Power, Government of India. So what is the vision for India? This is for the smart grid. Okay, the transform the power India power sector into a secure, adaptive, sustainable, and digitally enabled ecosystem that provide reliable and quality energy for all with active participants of the stakeholders. This is the vision for our India. What is the mission statement? Enable on demand access and availability of affordable, reliable, quality of power for all with optimal mix of, from here very important point, optimal mix of conventional and renewable energy sources. This is the reliable quality of the power for all the consumers with optimal mix. Optimal mix means they are going to mix renewable and conventional energy sources. That means thermal energy power plant and renewable energy plants. It's an optimal mix. Okay, this is the mission of the mission of the NSGM. So what are the pilot projects? It's already we have some pilot projects in India. There are plenty of projects are there in under Ministry of Power, which are completed in under implementations are as follow. That one: Ajmer, Assam, Mysore, Himachal Pradesh, Puducherry, Tripura, Telangana, Haryana, Gujarat, West Bengal, IIT Kanpur, and Manisha. So these are the places are there. Then under NSGM, we have some places are. It's a process is going on from the Chhattisgarh, Jharkhand, Odisha, and Rajasthan. So these places are under progress now. These data are available in our government website. It's a NSGM. It's a project website is available. If you want more details, please go through that. Okay, now I come to the point for the renewable energy sources. It's a distributed power generation. So what is a distributed power generation? So start from solar power, wind energy, so that is a small hydro, fuel cell, tidal is nearby that ocean area, and bioenergy. So these are the some of the distributed power generation source. So from here, hydro and tidal is only based on the availability. So the seashore area, if anybody is there, they can to use the tidal waves for generate electricity from hydro. So if it is possible, is nearby the small hydro is a the big dams are not possible for any everywhere. We can't to say that big dams are not a distributed power generation. It's a hydro power generations. That means another way. So whenever it's a multi-store building, it's a water flow is there now. From there they are going to fix the small turbine from the pipe, water flow pipe. So they are generate the electricity through the water flow. So that's why the hydro, I said here the distributed power generation, but it's a hydro plant. How you can think about, sir, how the hydro power plant nearby the consumer is not possible. But this, I said the hydro means from here where the multi-store buildings. So we have to use the flow of water. So that pressure we have to use to generate the electricity with the small turbines. Then bioenergy we have to use nearby the consumers, and fuel cell is possible. Wind energy is based on the availability of the wind, is not applicable for all the places. It's like that solar is in India, is I think is not an issue for the solar power plant. But wind energy is only for the, we need to check for the availability of the wind. Yeah, what are the mode of operations? So there are mainly three modes. So first one is a standalone mode. The standalone mode means we are going to generate the electricity for only for our home appliance. It's not connected to the grid. Then next one is a battery charging mode. This is a very current trend for the battery charging mode, because the EV electrical vehicles is come to the market, and most of the industries, the automobile industry, they said they are going to stop to manufacture the IC engines within 10 years. So after that, they are going to concentrate only the EV vehicles. So just think about in just 2030 or 2035, it's a 75 to 90% of vehicles are converted into EV. So just imagine how about the charging stations. So now the fuel stations are converted into charging stations. There is a there is a plenty of opportunities for the entrepreneur for in battery charging stations. So that is why now you can concentrate the battery charging stations is a vehicle to grid and grid to vehicle technologies are there. Then grid connected mode, that is a large power generations. So we are going to generate the electricity, then is connected to our power grid. It's a large, or is only for the large power generations. So this is the same thing. Okay, then next one is a hybrid renewable energy sources. So what is a hybrid renewable energy sources? We have to hybrid is that means we are going to combine more than there is a two different energy sources. So like PV wind or PV fuel cell or PV fuel cell wind. There are we have to combine so different renewable energy sources. There is a hybrid and generate the electricity. We have to hybrid PV wind, PV fuel cell, and the battery, the energy storage device, and other sources also. It is a hybrid system. So how we are going to hybrid the renewable energy sources? So we have, this is the existing technologies. So the existing technology are using the DC to DC converter and DC to AC inverter. Then it's connected to the transformer. Then it goes to AC buses. So these are the topologies they are using the earlier. So from here, what is the issues? So from here, the number of power electronics devices, it will involve to generate the more harmonics. So from here, at the same time, the control and quality of the power generation is very difficult and more challenges in this area. That's why after that, the next development, they are going to remove the transformer. Then instead of two inverter, they are kind of on single inverter for the two different sources. Here also we are not satisfied for the power generation and quality of the power, because of from here also harmonics levels also high. The next one, from here they are going to they are using the multi-level DC converter and DC to DC inverters. From here also we are not satisfied, because from here also it will generate the harmonics. Then they are facing some issues in the previous uh, topologies. After that, they are going to think about the multi-level inverter. It is a high voltage level and high power, high voltage applications. They are using the multi-level inverters. So in theory, the multi-level inverter has the design in high voltage level to regulate and improve the conversion efficiency and reduce harmonic content and the electromagnetic inference system. So the power quality improvement is one of the main advantage of the multi-level inverter in the renewable energy sector. From here, we have to connect more than one DC source to the input side, and we have to get the multi-level output from the sinusoidal waveform or pulse waveforms. We have to take the output of the inverter. From here, we have to reduce the harmonic content in the power conversion, resulting is a low switching losses and low voltage stress, is a dV by dt stress on the each switches. So then this is the, that's why we are moved to the multi-level inverter. So in the multi-level inverter we have the different types. So first one is isolated DC source, another one is non-isolated, there is a common DC source. So isolated DC source is we are using the cascade H-bridge multi-level inverters. From common DC source we are using diode clamp multi-level inverter and fly capacitor multi-level inverters. So from here, whenever is we are going to use the distributed renewable energy systems, is not a single common source. So we have the number of sources are there. So that's why the renewable energy systems, the cascade multi-level inverter is a more that means more alert, what is more suitable for the renewable energy sources for distributed generation. I'll let you know that why we are going to use the cascade multi-level inverter for the renewable energy systems. We know there is a three multi-level inverter topologies: natural, uh, point clamped inverters, and flying capacitor multi-level inverter, and cascade multi-level inverter. The diode clamped and flying capacitor multi-level inverters are using capacitor to develop the several voltage level, but it's very difficult to regulate the voltage of this capacitor. So that is the reason we are going to it's not suitable for the renewable energy sector. But the cascade multi-level inverter, what is the main advantage is there, we have to apply the asynchronous voltage as the input of the cascade multi-level inverter. At the same time, we have to get the permit more voltage level of the output from the cascade multi-level inverter. So that is the reason we are moved to cascade multi-level inverter. So these are some of the conventional cascade multi-level inverter. So from here, there are each sources. Example, if you consider this is PV, this is wind. If you can consider this is the fuel cell. So different voltage and different sources we have to connect in the multi-level cascade multi-level inverter. So from here also, our people are not satisfied because the number of switches is here. The each pair is 4 switches are there. From here also we are facing the harmonics. So how to reduce the switches? So after that we are going to implement. This is my paper is published in 2015 in Journal of the Fuel Cells. From there we are concentrate only one switch instead of the 4 switches. So from here we are going to reduce the harmonics. At the same time we have to reduce the voltage stress on the each switches. Then at the same voltage level we get from the output from here. I'll show you the output. This is the single phase. So this is the multi-level inverter for hybrid PV and wind and fuel cell system. This is the presently we are doing the research in this area. The cascade multi-level cascade H-bridge inverter from here it's include DC to DC as well as DC to AC. From here we have to connect different type of renewable energy sources. Then we get the proper output and is connected to the AC load. So how to control this multi-level inverter? We are going to use the artificial intelligence controller to generate the triggering pulses for the switches. I will explain that. These are some of the waveforms. The comparative study for the different number of levels and with the THD with the filter and without filters and number of DC sources. These are some of the proposed model we developed. Okay, I will move for some of the comparative studies. Fuzzy and phase comparative studies for THD power quality. So what are the benefits? From here we have to use minimum number of power electronic switches for the same level, generate the voltage, less space requirement, harmonics, improved power quality, easier to control. The lesser cost for the proposed system is 40% less as compared to the existing systems. So these are the benefits. Now we will move for the challenges. So what are the challenges for grid integration of renewable energy system? The first one, grid stability. So the stability is one of the major issue because whenever you are going to, this is not a smart grid, it's a normal grid. Whenever you are going to integrate the renewable energy system, so because the power grid is, example, the power grid is the power flow is more than 2000, 3000 megawatts power flow is there. So whenever you are going to integrate our small power gen of renewable energy sources to power grid, definitely the stability issue will be there. So some stability issues, so we need to maintain the stability of the systems. Reliability, because our renewable energy source is not reliable because it's purely depending upon the natural resources. Then voltage regulation for the static and transient stages, because the voltage, without voltage regulation we can't to integrate the renewable energy sources to the power grid. So the power, if you want to integrate the renewable energy sources to the power grid, that means the synchronization process. From that synchronization process we need to maintain the voltage and frequency should be same. Then only we have to synchronize with the two different AC sources. So that is another important challenges for voltage regulation. Power quality issues is a THD, power factor improvement, The energy management system, how we are going to manage the energy, that means optimum asset utilization, how we are going to optimally utilize our assets, that means the renewable energy power generations. Unbalanced power flow issues, optimal size and power generations, energy storage, islanding issues, integrating issues. So islanding issues, another important point is islanding issues. So because our renewable energy source is not reliable, we know that, because it is purely depending upon the natural resources. So whenever the sunlight is available, at the time only the PV generate the electricity. But at the same time, the sunlight is not constant. Is a morning to evening, is definitely the irradiation level will be changed. Okay, but how we are going to maintain the synchronization is another important point. It is possible to lose at any time the synchronization. That means that is called islanding issues. Then integration issues, protection issues, because from here a number of DC sources are involved. How we are going to design the DC circuit breakers? At the same time, we are going to convert into AC. The AC circuit breaker is presently is available, is not an issue. The AC circuit breakers, that means it's already well technology is available in digital protections also. Nowadays most of the countries are focusing the digital protections. And the renewable energy sources, another important challenge for the renewable energy sources is the MPPT method. So without MPPT method, we can't to generate the maximum power from the renewable energy sources. So we need to concentrate the different type of MPPT controllers, the optimized flow control, harmonic issues, filter designing, minimize the power distribution losses, economic and environmental issues. So these are the challenges. Is the again the technologies. So what are the topologies we are going to use in hybrid standalone and grid integration method? The power electronic devices, the selection of the power electronic devices. So whether it is IGBT or MOSFET, presently we have the SiC MOSFET is a high switching frequency. So normal MOSFETs, they are using 2000 heads for the switching frequency, but in SiC based MOSFETs, we have to we have to apply more than 20 kilohertz frequency, the switching frequency. So there is a possible is the design of the controllers. So what type of controllers? But we can't say all the controllers is suitable for all applications. So we need to select the optimum controller. And finally, we need to follow the international standards, because so THD, we are discussing about the THD, the total harmonic distraction. So total harmonic distraction should be less than 5% for voltage and current, then only is acceptable. If it is more than 5%, it's not acceptable. So that is the reason we are going to concentrate for cascade multi-level inverters and AI technologies to reduce the harmonics. Okay, I'll move for. So these are the some MPPT controllers for conventional method and intelligence controllers. So we know the conventional methods, we have PNO algorithms, incremental conduction algorithm, and voltage feedback and current feedback algorithms. So different algorithms are there, but intelligence algorithm is compared to the conventional intelligence algorithm, it will generate the maximum power compared to our conventional MPPT controllers. So intelligence controllers, normally we know the expert system, fuzzy, PSO, genetic algorithm, ANFIS, machine learning, deep learning algorithm, algorithm, bat colony algorithm. There are plenty of algorithms are there in MPPT controller. So if you go through in journals, I think more than 100 plus MPPT algorithms are there. So just to go through that. So from here I'm using for deep learning based maximum MPPT controller. From here the multi-layer systems, there's a neural network systems for that we are using here. these are some of the modeling and training data and testing validation data. Then we are going to check the output. Some of the simulation results with the different irradiation, different temperature, how the duty cycle will be changed. So these are the harmonics. So okay, I will go for some other slides. This is not possible to get now. Okay, this is already discussed. So okay, end of the topic. So what are the future research? There is opportunities to develop the hybrid artificial intelligence controller for grid integration and the standalone application of renewable energy systems. So we have to develop a high voltage based cascade H-bridge multi-level inverter for renewable energy systems, to develop various inverter topologies for hybrid renewable energy sources and smart grid applications. So finally, whenever you are going to concentrate, the smart grid is a future of the grid. So the smart grid system is not only for electrical engineering. The smart grid is a interdisciplinary area. So from here, the majorly we contributed a EEE, ECE, computer science, and instrumentation engineers. So majorly contributed for the smart grid applications. So this is the IEEE standard, IEEE standard 1547 and IEEE standard 519. They will provide some guidelines, design hybrid as well as grid integration of renewable energy sources. This is 2030 is IEEE standard 2030 is especially designed for smart grid. This is under progress. So probably this month they will release the IEEE standard 2030 data. They will provide all the guidelines for the smart grid related issues. And this is IEC technical committees. They give some standards. And this is our Ministry of is a present status of renewable energy in India. The Ministry of New and Renewable Energy is MNRE. So we are the fifth position in the global. So overall installed renewable energy capacity is proud to say we are have reached the some milestone, the installment of renewable energy sources in India. Okay, this I'm going to conclude my presentation. So in my presentation, the summary, I discussed with you the overview of AI and smart grid and national smart grid mission and vision mission and pilot projects and distributed renewable energy sources and various topologies involved in hybrid renewable energy system and simulation models. Then what are the major challenges we are facing integrating the renewable energy sources? Finally, some international standards. Okay. Thank you. So if you have any queries, we will discuss now.
Yeah, thank you, sir. Participants, the session is for discussion. If you have any queries or doubts, like if you want any research kind of collaboration doubts or whatever it may be, you can post the questions, or you can type the questions in the chat box also.
Good morning, sir.
Yeah, good morning, sir.
Sir, I have one small doubt, sir.
Yes, sir.
So our India also going to the HVDC transition line, sir. Means HVDC also
Yes,
going
yes.
on. So
Yeah.
in generation side, we can convert the rectifier, and in distribution side, we use the inverter. So my doubt is in inverter side, which type of level means that there are multi-level inverters is there, no, sir?
Yes.
Means that you can explain, sir.
Yeah, the multi-level inverter we have to use to generate that. Actually, the HVDC transmissions is a HVDC transmission. We are using more. The transmission distance is more than 500 kilometers, and we are and transmit the more power. It's a more than 5,000 megawatt power. So at the reason only we are moved to the HVDC transmission. Normal below 500 kilometers, we are not preferred for the HVDC transmission. There's a very high voltage transmission side. So after that, the HVDC transmission, at the same times, we have the different types of HVDC transmission system is there. Is a monopolar, homopolar, bipolar, and back-to-back connections. So there are different types of HVDC systems are there. So after that, so whatever that it's only using for the power transmissions. So from some of the advantages is compared to the HVAC transmission, the HVDC transmission is somewhat is good. The power losses is less compared to the AC. At the same time, the investment definitely the inverter converter stations, that is the cost is too high. But at the same time, what is the another advantage is the transmission line. So number of transmission line is less compared to the HVAC transmission systems. So from here, the inverter and converters, the design is very complicated one, because presently the Siemens and ABB, they are only on GE. They are focusing on HVDC transmissions. At the same time, the converter inverter, from there definitely the harmonics levels are very high. Presently, I can't to say, I don't, sorry, I'm not aware about they are using multi-level inverters or not, but they are normally used as stack inverters. Uh, if I want, I will check and let you know if they are using multi-level inverters or normal inverters. Because high voltage power transmissions, I'm not sure they are using multi-load inverters.
Thank you, sir.
Hello, sir. I'm Kiran. I have a few queries.
So the voice is too low.
Yeah. Can you hear me, sir, now?
Yes, sir.
Yeah. Yeah. This was a really good presentation, sir. You covered both, especially the power electronics as well as the artificial intelligence. So it was a good blend between these two. So I have two queries in both this one in power electronics and artificial. And first in this artificial intelligence, yes. With the implementation, you highlighted the improvement in the efficiency, the power quality, and maybe the stability of the grid and all. And we have seen some products, some like GE, ABB, they making the product level artificial intelligence, like Predicts, you might be heard, sir, in the wind and solar.
Yes, yes, sir.
I wanted to know, sir, mostly on the system level, means what is that value proposition? Because we know, yeah, it is definitely going to help. There is some advantages, but at a what proportion? With artificial intelligence and without. So, do we have some picture of that, sir, which is showing? See, this is the availability, efficiency, or stability without artificial and with artificial. I would like to have some picture if you have it, or you if you want to give me any reference of paper, that will be also helpful.
Yeah,
That is
definitely. I will answer.
one question, sir, and maybe I will put another question on the power electronics. You talked about this multi-level inverters. Yes, the 2 level, then we went to 3 level, and I seen your paper on the 13 level. Something you have made it, sir.
Yes.
One comment on that, sir, because what we seen in the 2 level, yes, there was a issue. Especially, I'm talking in the source or solar inverter. Yeah, the even though IEEE 519 was talking about 5% current THD, but
Yes.
our grid or our Indian grid or most of the globally grid were limited to 3%. And
Yes.
ideally,
Yes.
this 3 level itself will give us less than 3%. I mean, say 2 or 1.5, a very good inverter. So I would like to see your paper by making 13 level. What was the benefit? Means anyhow for THD aspects or power quality aspect or EMI, 3 level itself is enough. So
Yeah, yeah.
that
3 level
was
is 3%. Yeah, 3%. If it is provided, the 3 level is enough. Yeah. I will answer you. No issue.
yeah. Okay, sir. Yeah, fine.
Yeah. The first question. So with and without AI. So the without AI, we are using the PI controllers. So normally the controllers are designed by the PID. So most of the places in PI controllers we are using. So what is the issue? Means the PI controllers, they can't do change the values. That means they can't to take the decision. So whatever you are designed, the fixed value only we are going to use at the time. That means fixed values. PI values are fixed one. So if it is any sudden changes, the system is not perform that much level. But in artificial intelligence, they are monitoring in your system. That means the artificial intelligence, the data collections, that there are plenty of multi agents are there. That means sensors are there. They are sense the data in your system. So example, in my research work, our system is every off cycle I'm going to monitor my system. So every off cycle, the control signal also changed, because the AI based on the system performance, it will change the control signal. So what happens is that definitely it will increase the stability as well as the quality. We have to generate the quality of the power compared to the existing system. So existing systems means from there the predictive maintenance, and we have only the schedule. Then after that only we have to do that. Example in your car. So if you have the car, as an example, the oil change every 10,000 kilometers. So only we are going to change the car oil, the engine oil. So from here, so how to monitor the engine oil? So we need to check the engine oil frequently. At the same times, we need some in your dashboard we have the sensor. It will going to inform you only the oil level. If it is oil level reduced, it will inform you. But is the quality of the oil is not possible to inform you, because whenever it comes to the artificial intelligence, so is most comfortable for us. So it will sense the oil quality, oil level, then it will intimate you. So before 10,000, if it is example, your vehicle 10,000 kilometers, you need to change the oil is a normal conventional method. But intelligence method, what will happen? It will sense your informations. So exactly we are going to fix every 1,000 kilometers you need to check. It will inform you. So your oil quality, this is the oil quality, this is the level is there. So you have to run up to another 500 kilometers or 1,000 kilometers. Otherwise it will recommend you don't use the old oil, try to change your vehicle oil. So like that it will give the recommendation to you. This is interactive system. It's a AI. But in conventional is not interactive. It's like that is in the same application is we are applied in our power grid. If it is anything failure, it will change the path. Example, if any transmission line is shut down, otherwise any transmission line is broken, so we can't to transmit the power to the consumers. But whenever you come to the smart grid or the intelligent systems, it will, it is an interconnected source. It will look the new path for the reach the consumers. So that's why is more advantage in AI control. I'm sure I'm answer you for the AI. The next one, your next question is a power electronics. Yes, of course, you said the 3-level inverters is possible to interconnect the renewable energy system to the power grid. So from here we are discussed over the distributed generation source. So the distributed generation source is not a single source. So from there is a distributed generation. Is more than 10 or 15 or n number of generation sources are there. It will generate the different voltages. That's a asynchronous voltages. So we can't to connect the your 3-level inverter. There is only one source, but multi-source we can't to connect there, because the multi-sources, if you connect there, is asynchronous input. It's not a common source. But in your whenever you move to the multi-level inverters, we have to interconnect different sources. So PV, wind, fuel cell, whatever it is. At the same time, it's asynchronous also. Asynchronous because all are not same voltage level, because it's depending upon the climate. So that is the reason the multi-level inverters, we have moved to the multi-level inverter. At the same time, so compared to the 3-level inverters, so actually the 3-level inverters we are using the PWM pulses or sinusoidal waveform generations. So definitely the harmonics is higher than our multi-level inverters. So multi-level inverter, this is the advantage. At the same time, the multi-level inverters we have to generate without filter less harmonics. But 3-level inverters without filters, LCL filter or LC filter, the harmonics much more. So that is the reason we move to multi-level inverter for the renewable energy sector.
Okay, got it, sir. Thank you very much. Just to conclude this one. So on this multi-level, what I understand from you, sir, since I told 3-level, it was only restricted to solar or the PV array. That is the reason. But if you go
that
for
is a single
multiple
source.
source,
Yeah, that is
correct,
a
correct.
that is a single source. Yeah.
Got it. Yeah. So if source increases, there is a chances of variation. So 3-level may not able to handle. That is the reason you are going for more than 3-level. Got it, sir. Fine. And,
Yes.
and that first part, sir, this I got more information than earlier you told. But my specific question was on the value proportion with the islanding. You detailedly explained very good. But what my question was, see the efficiency without islanding. Suppose I'm just giving example, maybe 90%, power quality like voltage regulation was 10%, availability might have 80%. And I am just talking of number without islanding. So do we have any study done with islanding? Yes, these are the numbers before and after, just to give some proportionate differentiation. If anything is there in the paper, later on also you can share me that details, sir. Maybe
yeah,
you
I
are
will share you the details.
Yeah, thank you, sir. Thanks.
Yeah, thank you.
Yeah.
One more question in the chat box.
Yes, sir.
Small hydro can be obtained from large canals. The cubes of 2000 cubes, like a falling height of 5 to 10 meters in the large iteration projects. Is it possible that like a small hydro can be obtained from large canals?
Yeah, actually, I am not that area in the hydro plant because it's purely dealing with the fluid flow. It deals with turbines. It's purely is a mechanical and civil related bit one. Actually, I'm sorry, I'm not the position to say the answer.
Fine, sir. Fine. So that the questions are posted
That's
in the
purely
chat.
it's a purely related to the fluid mechanics.
Yeah, like
they only the
mechanical.
fluid mechanical experts only they know is it possible or not. We can't to say that because I'm purely a power system background.
Yes, sir. Like, sir, the for grid monitoring and all, like in solar power systems, grid monitoring, like, is it possible to like only identification is fine? Then how about that with this artificial intelligence to recover themselves, like?
Yeah, that is a smart grid. That's why the smart grid they are going to actually the multi agents are there. Whenever you are going to sense the data, they are continuously monitoring and condition monitoring system is there. So example in Vistas in Chennai Vistas, more than 70,000 wind farms are monitoring in single place. It's a big data analysis. If any fault is there, any fault or if anything is required, they will control from here itself because they are using the multi agents and IoT technologies and predictive maintenance technologies. There are plenty of things are there. So now our system is not fully smart grid. So whenever you comes to the fully smart grid system, the configurations and self healing power is possible in the smart grid system. That is one of the advantage for the smart grid compared to our conventional grid. There's changing the control signals. That's why I said is every half cycles we are monitoring the system performance. So just to think about the data's level is a big data. Example from here they said 70,000 wind farms they are going to monitor the vibration and frequency. So many parameters are there. So they are going to monitor, they are going to send all the data to the cloud because the big data analysis. So this is possible in a smart grid.
Like it's completely on the bidirectional communication.
Yes, yeah. That's why the
end-to-end
two-way communication. Yeah, two-way
Yeah.
communication.
Okay. Fine, sir. Any other questions from the participants, or shall we conclude the sessions? Participants, you can unmute also.
Hello. Hello.
Hello.
Sir, what is the potential of the DC in the distribution side?
I can't get you.
In the distribution side, what is the potentiality of DC distribution?
Sorry, sir. Voice is breaking.
I will type in chart.
Yeah.
So like I think. Yeah. What is the potential of DC distribution in India? Like we are using AC, right? Or like what is the potential of
Yeah,
DC?
already is there in DC, not DC distribution. Is we have only in the DC transmission.
Yeah.
We have only DC transmission. HVDC transmission only is there.
Yes, sir. So all we are using that AC, then the distribution.
Yeah, if people are ready, if people are ready to change all the systems into DC, then we will look for the DC distribution.
That's what, like.
So if you want, if you want in your home, want to use any DC, then you can use any rectification system. Then you can rectify AC to DC and you can utilize. But it's not available, I think, DC distribution. So DC distribution is only for particular industries. If they want, they need to rectify.
Yes, sir. Yes, sir. Like
what about the future distribution of smart grid? The future only is smart grid. There is no choice. Definitely, I think it's take too much time. It's nearly 20 to 25 years. Actually, US also they are planned to implement. It's totally implemented in smart grid in US 2030 or 2035 itself only. So it will take too much time. But
yes,
in future only smart grid.
Yeah. Fine, sir. Fine. I think no other questions. We can conclude the sessions also. Like.
Yeah, thank you.
Thank you, sir. Thank you so much. Thanks for the acceptance of our invitation and deliver the wonderful and more informative sessions. You started from the basics, AI basics, and you have covered the things like how it is to be interlinked of AI with our smart grids. You have opened our eyes with the complete basics. It's we are all the doubts are clarified, sir. Like with your presentation, more informative sessions, sir. More comments also, like in more interactive and information session, we are receiving the comments also. Thank you, sir. Thank you so much.
Thank you, sir. Thank you for giving this opportunity. Thank you for all the participants. Thank you.
Yeah, on behalf of KL, thank you very much, sir.
Yeah, thank you, sir.
Thanks for your presence, and the next session will start by 12 o'clock.